Silence. നമുക്ക് ടെസ്റ്റ് ചെയ്യാനുള്ള മൈക്ക് എല്ലാരും കൂടി ഞാൻ ഓൺ ചെയ്യുമ്പോൾ എല്ലാരും കൂടി ഹലോ എന്ന് പറയണം കേട്ടോ.
Hello.
Oh, amazing energy. Good. We'll wait for 2 more minutes to kickstart this awesome event. Yo, man, science is definitely awesome.
Silence.
Hello everyone. Hi. Welcome back to C-STEM sessions. I'm your host Maitreyi. I'm from American India Foundation, and we are here to start off with the actual curriculum-based sessions today. So today's topic is, as you all know, today's topic is chemical reactions. You must have studied this chapter in your classes, in your science class, and you must know how chemical reactions, chemistry plays part in your daily lives. And today we will be seeing how concepts from this chapter can be used for everyday problem solving, and how you make careers from it. And without delaying it any further, let me ask Shashank, are we ready to go? Hi Shashank. Hi Neha.
Hello, ma'am.
Hello, I'm all ready with my lab coat. Okay. So because chemistry, I don't want to
let's get started.
take risk. Yeah. Hi guys, what's up? I need some energy. So make some noise all together. What's up? No energy. Okay. Are you all ready?
Yes, sir.
Okay, that's really cool. Yeah. So what we will do is, I request not only you can talk to us, you can also type your queries, your answers, everything in the chat box. Okay. So let's get started. I'll clean up my table. Okay. Ready. Okay. So now I'm going to do first experiment. Oh, it should be little whooshy, boom. Correct. For that boom experiment, I want you to observe, and I'm going to ask few questions based on it. Okay. Are you ready for that? Okay. So what I have here with me is this one. Okay. What is this? Very, see this? Very strong water bottle. Correct? Are you able to see this?
Yes, sir.
Okay, good. Now, I want my so-called safety glasses. Okay, so now I'm going to take this one. I will not tell what it is. Okay, secret liquid. So I'm going to pour around 5 ml of it inside the can. And I'm going to mix it well. I'm going to ensure that liquid vaporizes and creates some vapor inside this can. Okay, there is a request I have for all of you. I do not want you to try this experiment yourself. It's a very extremely dangerous experiment. Only people who have lots of experience, experts can do it. So request to not to try this experiment on your own and never try it. Okay, this is one amazing experiment. I always loved it and I have done it hundreds of times. Okay, so let's have some lights off. Okay, see what I'm going to do now. So that inflammable liquid is what I have put inside. Now I am going to put some fire inside. Let's see what happens. So I want the countdown, guys. I want that energy for this Ushi boom experiment. At the count of 5, all together. Oh my God, look at that, look at that. It's like one engine. Awesome. Now I think fire is off, completely off. Now I'm going to close this here. See what happens. Okay, let's have the light on. Are you able to see this? What happened to the bottle? Almost pushed. Correct? Now I'll try it again. Shall I try it again? Okay. Okay. I'm going to try it again. Again, I'm going to put that liquid inside. See this? Okay. Now I'm going to do in front with the light on. Okay. Again, I'm going to ensure it's everywhere. Correct? I'm going to keep this and I'm going to put the fire in. What will happen now? What will happen now? There'll be a fire out, right? Yes. But nothing happened. I'll do it again. I'm going to lead it again. See this? Again. It's not working at all. Correct? So I have a quiz on this now. Tell me what happened. Why first time it went boom, second time nothing happened? Why? Anybody would like to answer? Would like to type down? Okay. The fluid which I put inside was a very inflammable liquid. When I put the mastic inside, it burned. While burning, it consumed all the oxygen inside. Correct? There's not much oxygen, rather water vapors and carbon dioxide inside. It was a combination reaction where that inflammable liquid reacted with O2 to produce CO2 and water. Next time when I tried, there was no air inside. So there was air, but there was no oxygen inside. So that did not help combustion. Awesome. Now tell me, whatever I did, was it a physical change or a chemical change? The complete thing. See this? There are water vapors inside. The water bottle is almost deformed, and there are some fire coming out like fire engine, and so many things happened. Someone said it's a chemical change, which I already explained. Alcohol burnt, combination reaction. What other thing happened?
No. Exothermic reaction.
Fantastic. It was an exothermic reaction. Lots of heat produced. Fabulous. Then the bottle got physically damaged, right?
It is melt.
Yeah, it got physically damaged. So is it a physical change or a chemical change?
Physical change.
Physical change. Okay. Same example. Let me try with one more thing. Example, I have camphor here. What is this? Camphor. Okay. You know what is camphor, right?
Yes, sir.
Karpur. So now I'm going to burn it. Now tell me, burning of camphor, is it a chemical change or a physical change?
Chemical change. Sublimation.
Burning. I'm burning it. When I'm burning, see this. Now, rather I'll burn it. Okay, check this out. Are you able to see that? I'm burning it. Is it a physical change or a chemical change?
Chemical change.
Someone said physical change.
Chemical change.
But where is sublimation happening? Someone said it's a physical change because there is a sublimation. But it's not a sublimation, right? It's actual burning. There's an oxidation. Isn't it? Isn't it?
Sir.
Some are typing even physical change. Okay. I'm going to clarify that confusion right now. What I did, I extinguished it by closing it with a beaker. Now, what I'm going to do is, I'm going to keep the same Karpurs. I'm going to keep the camphor here like this. And I'm going to put this beaker on the top. I'm going to burn it from the bottom. Now, camphor is not getting burnt. Is it not? Is camphor getting burnt?
No, sir.
What's happening in this case?
Sublimation.
Sublimation means you mean to say the that camphor inside is changing its state.
Yes, sir.
Are you sure? I'm going to show now. Check this out. The camphor is not at all there. Where is the camphor?
Gaseous state.
Now, gaseous state. Now, if I'm going to close it and leave it for a minute, zoom down. Little more. Less. Okay. Now it was in the gaseous state. Now when I kept it for some time, see that the gas has become solid again. Correct? The Karpur, the camphor did not turn into liquid state. It directly turned into gaseous state. When we allowed it to cool, it again became solid. Now tell me, camphor, burning of camphor, sublimation of camphor. Are they two different things?
Yes, sir.
We always get confused when we say burning of camphor is a physical change. That's what we always remember it as. But that's a wrong information. Correct? It's not burning. Someone saying I'm not audible. Am I audible properly?
Yes.
Okay.
Yes, sir.
Please check it out. I think there must be some issue at your end. Please help yourself. Okay, awesome. So now you can see lots of deposition of the. Are you able to see the deposition of the camphor?
Yes, sir.
This is a physical change, but burning was a chemical
change.
Perfect. So coming back to physical change, tell me different types of physical changes. One is state change. We all know, correct? States of matter. Apart from that, will there be any other state change we see around us?
Changing of shape.
Very nice. Changing of shape. Then the shrinking or changing the shape, getting broken. All these are change in shape. Then
Cutting.
if I put, for example, corn flour in water, what would happen?
Dissolve.
It will not dissolve, but it will get mixed up and it'll become a sort of a slurry stuff, right? Or if you make it more, it will become an atta. So that appearance will change. It will become wet. Even all they are physical changes. Okay, coming back to state change, tell me how many states of matter are there?
3.
Okay, guess one more time. Someone saying 4,
5.
solid, liquid, gas, and plasma.
5.
Another one is Bose-Einstein condensate. Okay. Oh my God. What is this Bose-Einstein condensate? I'm sharing my screen. Okay. See this now. Are you able to see my screen? Awesome. It's such an energy, man. I love this energy. Superb. So check this out now. Though this is sublimation of camphor, which is a physical change, and burning of camphor was a chemical change. And these are the different terms used for different state changes. Freezing, melting, deposition. What happened the opposite of sublimation? What happened to the camphor? Very good. That was deposition. Yeah. Then evaporation, condensation. Fabulous. Now, if I heat more, any gas you take and heat furthermore, it becomes plasma. Nothing like it's an ionized gas. Maybe I'll show it in one of the classes how that ionized gas look like. Okay. So that is plasma. If you cool any gases at extremely low temperatures, then it will become Bose-Einstein condensate. You know who is Bose? He's an Indian. Someone guess his name? Not Subhash Chandra Bose. Subhash Chandra Bose is a freedom fighter. This Mr. Bose is a scientist. Not Jagdish Chandra Bose. He's more of a biologist. Also worked on physics related to radio waves. This Bose is Satyendranath Bose. Okay. Satyendranath Bose. He worked with Einstein. Okay, and is their name. He worked lots of these state changes and related to what I call as bosons. How many of you know what bosons are? Don't worry, again I'm going to take that matter somewhere later. Bosons are those subatomic particles. Even the bosons are named after Satyendranath Bose. Okay, so not only these 5, there are more than 20 states of matter. Oh my God. Difficult to trust, right? Okay, so there are something called as fermionic condensate. Okay, there are something called as superfluids. There are more than 20 types of states of matter available at a special conditions. But normal conditions, day-to-day life, we'll be able to see 4: solid, liquid, gas, and plasma. Bose-Einstein condensate at a very, very particular temperature and pressure. But this fermionic condensate, superfluids, these are all at a special scenarios. If you want to know more about them, just go to Wikipedia or go to Google and type different states of matter. You'll be able to find those amazing list. Okay, it's a cool fact to know, is it not?
Yes, sir.
Yeah. So I'll go to the next page now. So next I want to talk about is whatever I'm doing, guys. I'll be doing some crazy experiments. I request not to try them. Safety first, because I'm practicing this them so many years, many years. So my request not to try any circus activities at school without anybody's permission, also without anybody's supervision. That's a request. Will you please promise me that?
Yes,
Great. So, okay, now only one thing I want to take. I'm very sure you guys know all these things. There will be temperature change in exothermic endothermic reaction. There will be color change. There will be evolution of gas. There will be formation of precipitate. In this one, it says change in the state. Will chemical reaction lead to state change?
Yes, sir.
Yes, sir.
Then it will become a physical change, right? How are you considering it as a chemical change? If water is becoming water vapor, it is a physical change. Then why are we saying that there will be a change in the state during chemical reaction? How can we say that? Okay, it is like this. H2 plus O2 will become H2O, right? H2 is a gas, O2 is a gas, but H2O is water. It is not the change of state for the same compound or the element, but it's for the product. That is extremely important to consider. The product which has become, which is a new product. There is not state change for water itself. Hydrogen, oxygen reacted to create water. Doesn't mean that there is a state change of water. Water was in vapor state. It become condensated to become water. No. The product which produced was of a different state compared to the reactant's state. Get it?
Yes, sir.
Awesome. Let's go to the next one. Easy. So always people get confused with chemistry. Chemistry in next 3-4 classes, I'm going to make it so easy for you. It's nothing but addition, deletion, and movement using heat, acid, base, and water. Heat, I meant to say when heat, that will make things react with oxygen usually, or maybe any other gases. Heat means creating that environment for gases to react with things. But otherwise, water, acid, base, and heat, maybe oxygen, only mix of those things becomes chemistry. Shashank, that easy it is. Definitely there will be lots of exceptions, but that is what it is. Okay, let's go to the next page. Okay, I'm very sure you guys will know all this. Okay, so let's I do not want to deal with this because there's lots of theory here. This booklet, the booklet which is given to all of you, if you received the kit, will have all this information. You can refer it whenever you want it, the way you want it. Okay, as a guidebook. But I do not want to go in detail here. But I want to show a couple of experiments related to it. For example, ethanol experiment we saw. When the ethanol burned in oxygen, it became boom. That CO2 and water was produced. You can see lots of water vapor here. Are you able to see lots of water vapor here? The transparent one became almost like foamy, foggy. Is it not? That's all water vapor. Okay. So even that is also I'll not say a state change, but state is different from the reactants. Okay. Then I would show you the next one, the decomposition one. This I have one cute experiment to show here. Okay, what I will do is it's the same experiment what we did last week, but I'm going to do it in a controlled manner. Okay, and I'm going to show you some magic. So what last time I did not explain you the science behind that boom, that oozing experiment. Okay, so now same thing I'm going to try here. Okay, are you able to see this? Zoom out a bit, please.
Yes, sir.
Okay, nice. So what I'm adding here is hydrogen peroxide. I'm going to explain you why peroxide, why not double oxide or monoxide or whatever. Let's see, trioxide. Okay. Hold on, guys. We're connecting the camera again. Are you able to see me now?
No, sir.
Now?
Yes, sir.
No,
Okay.
sir.
Yes, sir.
Okay. Okay, good. Now what I have taken here is almost 50% concentrated H2O2. Okay, H2O2. Okay, if you want to write it in your book and equate the equation, balance the equation by then, I'll be very happy. Because it is a very 50 to 60% concentrated, H2O2 will become what? H2O and O2. That's a decomposition reaction. I'm going to dilute it by adding some water. Okay. Also, I'm going to put some soap. Always, whenever you're doing the experiments, you're supposed to put all the caps on. Okay, keep other things out from the screen. See this? This one, this one, this one, everything is out. Now, next one is safety is extremely important. Safety goggles. Okay, I'm going to mix it very well. And this is a very controlled reaction. It will not ooze out like last time. Okay, now instead of liquid, liquid will make it react very fast. Liquid. So I'm going to put this catalyst. This is Ki. What is Ki?
Potassium iodide.
Very good. Oh, awesome. Are you able to see that?
Yes.
Now, what is a proof that what is coming out is I did it in a very controlled manner, correct? So not like last time, it like went meters high. Now, see what I'm going to do. I said, what I told is it will decompose, the H2O2 decomposed to become O2 and H2O, right? Should be what? Oxygen, right? If I'm going to put this here, okay, it went off, hold on. See what will happen. Are you able to see this? Again, I'm turning off. Look at this. Are you able to see that?
Yes, sir.
Yes,
sir.
So it's automatically catching fire. Correct? See this again.
Yes, sir.
A bit down, please. So I'm just what I'm putting only it's for some ignition temperature. Otherwise, water is also there that will reduce the heat. I'm going to take one more. So this is a proof that this is the foam which is coming out is a mixture of water, foam, and oxygen. Very nice. See this again. At least bit of that light is required. The fire is required to make it work. Here. See that? Is it awesome?
Yes, sir.
Yeah. So I'll try the same thing differently now. Let's see. I'll show you instead of foam. Let's see what happens. I'm going to keep it aside. So what I'm going to do is same stuff. I'm going to take it in a smaller tray. Are you able to see this? Okay. See now. Okay. Now it's the same stuff. What I'm doing here is I'm going to take a small Ki, very, very small. I'm going to put in this H2O2. So there is a, you're able to see the color change inside? Yeah, there is a color change and slowly the reaction is happening. Okay, we will wait. Okay. What is the gas being produced inside? Oxygen. In another place, what I will do is, meantime, the reaction accelerates. Okay, I'm going to take citric acid. Okay, better I'm going to keep them away. I'll take the tray out. Okay, I'm going to put a citric acid in another one.
Sir, liquids are not visible.
Okay, little more down. Okay, I'm going to put a baking soda. So now what will happen is, See this now. One place I created oxygen. Here oxygen is being produced. And in another place, what is being produced? Citric acid and baking soda. What is being produced? Carbon dioxide. Here I'm producing carbon dioxide. Here I'm producing oxygen. And now see what happens now. Magic. 3, 2, 1, go. Wow. Fire on, fire off. It turned off completely. See this? On, off. See this? On. Automatically it's catching fire. Wow. Awesome. Off.
Yes, sir.
Now it's not happening. Can someone tell me the reason? On.
Because
Off.
of, sir, oxygen and carbon dioxide.
No, here. Look at this. On, off. I'm just taking this near to it. See this? Oh.
Oxygen gas is released.
Correct. Now see what's happening. Look at this one. Oh my God. Vibrant. The reaction is going vibrant now. Now if I do, see what happens. The water, what is boiling here now? What is boiling?
H2O.
H2O. Water is boiling. So is it an endothermic reaction or exothermic reaction?
Exothermic.
See, if I keep it now, it will not catch fire. Why?
Hydrogen also releases.
It's also releasing vaporized
Hydrogen.
water, which is an extinguisher. Because there is an extinguisher also, water, which is not allowing oxygen to react with this. Awesome?
Yes, sir.
Okay, now this is extremely hot. I am going to take this away. Now let's think of the other thing. Which is other thing? Okay. This fellow. What is being produced here?
Carbon dioxide.
Okay. So meantime, I will do one thing. I'm going to lit some candles here. Okay. Why I'm showing this experiment is, guys, always, whether you learn from your textbook or not, whether you learn or not, don't you think experiments, reactions in the nature will continue to happen?
Yes, sir.
Then why should we learn about? Then why should we learn about chemical reactions? I'm going to clean that place till the time you tell me. When we know that reaction is anyways going to happen, okay, anyway the things are going to happen, why should we learn about chemical reactions? Would like to type it or you want to answer? Let me know. It's such a difficult thing. Balancing equation is so difficult. Even remembering the names is difficult. Still, why should we learn about chemical reactions?
Sir, because it makes new substances.
Because?
Sir, because it makes new substances.
No, sorry, I'm not able to understand what you're saying. Someone is saying
Sir,
because of the.
it makes, Sir, because it makes new substances with new properties.
Okay. So it will make us understand new properties. Someone said it's for better. It makes learning better. Do you think only to make learning better we have to learn about experiments, reactions? I do not want to have fun doing that, yeah. But rather, I watch superhero movies.
Sir, to understand what is happening around us.
Okay. Why should I know? Will it help me live a good life? This is science. Science is like pure, right? Science is like pure mom's love. It is without no expectation. You are learning. You are knowing the nature around you. But technology is that selfish guy, right? If something is happening in the nature, Why can't I make use of it?
To
So how
explore
are we
new
making use of
things.
this knowledge?
To explore new things.
Okay. If you, it's like a hobby, you are saying. Explore new things, have fun. Everything is related to hobby, right? As an making our life good, life better. How is it is useful? Why should I know about it? Only in terms of engineering I'm talking about. Engineering is where it'll solve my problem, day-to-day problem.
To create new things.
Very nice.
Sir, we have already studied this. Please tell something new.
Correct, like metallurgy. Without these chemical reactions, reaction with acid, base, whatever it is, we wouldn't have extracted metals, right? Imagine there, we wouldn't have, if those early scientists wouldn't have experimented whatever they got, ore, soil, whatever they got from the nature, if they wouldn't have heated it up, if they wouldn't have put it in water, you wouldn't have boiled it with water. Even what if they wouldn't have passed steam through those ores? What if they wouldn't have put them in acids and bases? So what would have happened? They wouldn't have extracted metals anytime in their life. We wouldn't have been using all these things, this one, whatever I'm wearing in life, right?
Yes, sir.
Yes,
Yeah,
sir.
we should love chemistry and to the detail possible, including organic chemistry, stoichiometry, ionic reaction, oxidation, reduction, cathode, whatever the complications it goes to, we should know them so that we will be able to create that beautiful engineering product which we want, from paint to glues to whatever it can be. One of the example is this. This is one of the earliest invention of mankind. Okay, they did it while preparing wine, while fermenting wine. They found this amazing experiment. Okay, I'm going to see this. People just 200 years back did not know there existed carbon dioxide and oxygen. What is being produced here?
Carbon dioxide.
Carbon
Now,
dioxide.
now I'm going to put the carbon dioxide inside this one. Am I pouring it?
No.
No, no, sir.
No,
I'm not
sir.
pouring the liquid, but I'm pouring the gas.
Yes.
The gas, carbon dioxide is one of the densest gas in the nature. It's going and setting down in this beaker, in this conical flask. Oh my God. Is it true or not? Whatever
Yes.
the carbon dioxide produced here, I'm pouring it in another conical flask. See, there is no liquid here. Are you able to see any liquid?
No, sir.
Nothing.
It is
I'm
in gaseous state.
Yeah, I'm going to put little more baking soda. Okay, I'm going to prepare more gas, and this don't worry about the color change. By mistake, it was some potassium permanganate fallen there. See, I'm pouring all the gas from one beaker to another beaker. It's a gas being poured, not the liquid. Carbon dioxide is invisible. Okay. Is there any carbon dioxide inside?
Yes, sir.
Okay, let's see what will happen. Zoom out. Let's see what will happen now. Oh my God. Oh my God. Awesome.
Yes, sir.
So is this conical flask empty?
No, sir.
No, it has what? Carbon dioxide. So
Carbon dioxide.
what is the learning from this? Carbon dioxide is a denser gas. It can make a blanket of that on the fire. It can be used as a fire extinguisher. That is the application we should lead to. Don't worry, Shashank. Will this experiment help me in my exams? That also I'll come. Definitely, my classes will be half for fun, application, STEM based. Also, half of the class, definitely I'm going to cover some of the portions and some of the techniques of cracking exams. Awesome?
Yes, sir.
Okay. Okay. So definitely whenever we are learning something from your textbooks, always wonder, why am I learning? What are we going to achieve it? What will be the application? So always you should think of that. Okay. So this is about our decomposition reaction. The decomposition was only the first one, that is hydrogen peroxide becoming water and oxygen. Later water started boiling air. So it was an exothermic reaction. Is it not?
Yes.
Okay. Now, before some technical things I want to ask here to know your prior knowledge on things. Now tell me, in this the picture in the left hand side, electrolysis, the green one, what is this? Is it an anode or a cathode?
Anode.
It's a cathode, right? Minus is written here, right? Cathode is what? Cathode. It's not cation. Cathode. Cathode is negative.
Negative.
Because cathode is negative, negative will attract what kind of ions?
Sir, positive ions.
Those positive ions are called cations. Cathode is negative, but cation is positive. So don't get confused here. What I remember is like this. Last time also told you. Cathode attracts cation because cathode is negative. It attracts cation. So cats are positive. So you can have your own logic to remember. You are a good memory power, good. Or otherwise, these kind of, especially 0-1 kind of a definitions like anode, cathode, reduction, oxidation. Such a confusing stuff here because there is no only digital 0 or 1. It can be reversed also if you get confused. So always way to remember is last time I told you anode is positive where an ion comes there and anion are negative. A negative ion, an ion, a negative ion. Remember one, rest all is magic. Anode, anion comes to anode because positive attracts the negative. Similarly, otherwise also cathode attracts cation, which is positive. Good. So H plus ions, cations are coming to cathode and O minus are coming to anode. Superb. Let's go to the next slide here. Okay, single displacement. Don't worry, I have given you copper sulfate. We can try it in a place also. It's a very simple experiment. Maybe I'm going to deal more with this during our. Tell me, guess. Okay, I don't think the chapter would be over by now for you guys. Metals and non-metals. Definitely, I'm going to cover more there. But see, this is iron. This is copper. If I'm going to put the copper here, the iron nail here. See that what happened? Is there a color change?
Yes.
See this? There's a brown. It became brownish. I'll use one more nail. See this now. Are you able to see this?
Yes, sir.
Iron. I want you to write down Fe plus CuSO4 will become very quickly in a fraction of a second. This brownish thing happened. This is what? Copper plus. If I keep it for more time, this will become greenish, and that is what?
Sir, ferrous sulfate.
Would you please write down and balance the equation? I think this is one of the most favorite and most used experiment because why? Because everything is safe except the nail. Dangerous. I'll give you a minute to balance the equation. It's already balanced. Oh, so lucky you guys are.
We know about it.
Awesome. It's already balanced. Nice. Okay, the next one. This is my favorite reaction. Okay. How many of you have seen this reaction?
Yes, sir.
This is like, I know. If you have seen it, your teacher have shown this to you. Fabby. Awesome. Otherwise, I'll show it. Okay. This is PbNO3. Means what?
Potassium.
PB.
Potassium nitrate.
Okay, lead nitrate. And this one is Potassium iodide, Ki. I'm going to take Ki here in this one. Okay, and look at, are you able to see this now? What is the color expected?
Yellow.
Yellow, yellow? Yellow, yellow?
Dirty yellow.
Not dirty fellow, smart fellow.
Golden fellow.
Golden fellow. See that?
Yellow precipitate.
Yes. Yellow precipitate is formed. Now, if I heat this, okay, we tried it, but I don't know. Something is visible. Oh, down, down. If we heat this and boil it, after some time, that the precipitate will get dissolved in water, and once it cools down, you'll see beautiful golden crystals. But now already time's up. I doubt it was till now the golden crystals were here, but I think we lost them. Let's see, maybe to some extent they might be available. Are able to see the golden crystals?
Yes, sir.
Not as beautifully as I wanted, because again I have to heat it and cool it down. It will take half an hour. Maybe you can ask your teacher to do that for you. What you need to do is same thing. Lead nitrate, potassium iodide, lead nitrate, then mix them and heat it till it become colorless. Colorless means it's being dissolved in water. Then cool it. Watch it after half an hour. Beautifully, you'll be able to see the golden. Now I'm able to see bit of it. I don't know. Are you able to see now? Glittery, glittery stuff. Oh shit! Again, I mixed it. I shouldn't have done it. I shouldn't mix it. Slowly they'll settle. Now it's coming. Are you able to see those glittery, glittery stuff?
Yes, sir.
Now they are visible, I think. Yes, sir. Now they are visible. Wow. Awesome.
Yes, sir.
This reaction involved both chemical change and also physical change. Dissolved, after some time, they became crystals. Crystallization is a chemical change or a physical change?
Both.
Both. Awesome. Both. There will be definitely change in the molecular structure. Now you'll be able to see beautiful crystals. Is it not?
Yes, sir. Okay. It's awesome.
Yeah, awesome. Science is
Awesome.
awesome. Good. Now let's go to the next one. So, would you please balance this equation for me?
Okay, sir.
Okay. PbNO3 twice Ki. Please balance the equation. PbNO3 twice plus Ki will become PbI2 and KNO3. What I have, is it balanced or no? Is it a balanced equation?
No, sir.
No. The best way to balance is I'll take always write Pb. Don't create NO3 separately, because NO3 is together here. You can keep NO3 as a together item here, and K and I here also same thing. So Pb same, K same. I is different, and
Sir, put 2 before Ki and 2 before KNO3.
2 means 2 Ki and 2 Ki. Try to balance 2. So then 2 NO3. Oh, that's fabulous, man. Perfect. So 2 will come here and 2 will come here. Correct?
Yes, sir. Yes, sir.
Hold on, guys. Just a moment, please. Okay, let's go to the next one now. Okay, this also, the whatever I told you, citric acid plus, oh my god, very difficult to balance, but still we can balance. Okay, let's go to the next one. Next slide of it. So these are the reactions, because I'll not be able to make you experience these exothermic, endothermic, right? What I have done is there are some chemicals which are given in your kit. Next week, I'm going to tell you how to use the chemicals and materials from your kit to create this fun experience. Okay, that we'll do it in the next class. I'm going to at least 5-6 experiments will conduct for the chemical reaction from the kit we have. So we'll wait till then. Okay, then let's go to the next one. I'm going to discuss more of exothermic, endothermic again when you will be doing the experiment on your own. Okay, so this is a thing I wanted to deal here. What is the difference between valency and oxidation state? Okay, very simple. Oxygen valency is, okay, I have a question here before I answer. Valency of oxygen is -2, +2 or 2?
Sir, it is 2.
Okay, someone says 2. I want more answers. Is it 2, -2 or +2?
So -2.
Some are saying -2, some are doing 2. Okay.
Sir, 2. Sir,
2.
2.
Valency is never be negative or positive. I'll tell you why. Okay. That's the reason I took this special concept for all of you. Valency cannot be -2 or +2. Valence is always 2, 1, 2, 3, 4. Either one of them. Maybe it can go up to 7 sometimes. Okay. Valency is a whole number. Correct? It cannot be an integer. Point number 1. Why? Because it is a combining capacity of an element, of an atom. For example, oxygen, it can take 2 electrons. It can take. But how many it can take? 2. Calcium can give. Valency for calcium also is 2. Oxygen is also 2. Sodium is also 2. 1. Chlorine is also 1. So valency will never be minus and plus. It's always a whole number. Good to go?
Yes, sir.
And can valency be 0?
Yes, sir.
Yes, noble gases have valency 0. There's a difference between valence electron and valency. Okay, that I'm going to deal in metals and non-metal classes in detail. You'll be partially definitely knowing it nowadays, but I'm going to go detail around it. This valency, will valency change for the same element?
Yes, sir.
Yes, sir.
Okay. One element can have multiple valencies depending on the compound it is going to form. Correct?
Yes, sir.
Especially, yeah, last time I was telling about my profession, right? I was a ship designer, ships. And I worked for big, not boats, big ships. And I was working on this project where we are fixing this component called as scrubber. This very huge machine which is connected to the exhaust system of the engine. Do you know the size of engine in the car? The size of the engine in the car will be this big. 1 feet by 1 feet, maximum 1.5 feet. But in ships, the engine size was bigger than room where I'm sitting. It's double than that. Maybe the room where you are sitting, that is the size of the engine. Imagine amount of exhaust gas is going to release. Correct? When these petrol, diesel, HFO, DOs are burned. Petrol is not usually used. Usually diesel oil is used, or there is something called as HFO, heavy fuel oil is used in ships as a fuel. That is going to produce, because of the high temperatures, not only the combustion is happening, also the nitrogen and sulfur in the gases in the HFO, in the petrochemicals, also the nitrogen gas will change the chemical compositions and form different types of oxides of nitrogen and sulfurs, like sulfur dioxide, disulfur oxide, sulfur trioxide, sulfur monoxide, nitrogen oxide, dinitrogen oxide, dinitrogen trioxide, nitrogen monoxide. So they are called as, because the numbers are always varying, they are called as NOx and SOx. X is that instead of 2 and 3, they're calling it as X. We call them as NOx and SOx. If NOx and SOx, that is nitrogen, different oxides of nitrogen and sulfur, if they react with water, what would happen? If NO reacts with water,
They will form
acid.
and sulfuric acids.
Next week I'm going to deal about it later, little more in detail. Non-metallic oxide, nitrogen oxide in water will produce HNO3. That is acid. Non-metallic oxides are acidic in nature. In water, they are going to produce some acids for sure. Same is the case with sulfur also. Sulfur is a non-metal. Non-metallic oxides are acidic in nature. In water, they are going to produce acids. Don't worry, it's a little confusing in the first class. I'm going to deal with it little better in the next class. So what we used to do, we used to wash, literally wash by sprinklers, this exhaust gas. The exhaust gas which used to come out from the exhaust pipe, we used to wash that with NaOH, that is basic element solution, so that the NOx and SOx are reduced before it is left to the atmosphere. Definitely this soot, the fine soot of carbon monoxide, dioxide also was taken down by these scrubbers. Amazing application, right? In real-time scenario, it reduces lots of pollution. Great.
Yes, sir.
So the valency would vary in many of the elements, but oxygen usually same. Okay, but nitrogen and sulfur, which I told you, they would differ always. Sodium always same, +1. Not valency, the oxidation state. I'm going to tell what oxidation state is right now. Now valency is that number, whole number, right? But oxidation state is that number where that particular element is able to receive or give out electrons. It can be negative and positive. For example, look at this one, potassium. It's the same chemical with little variations. One is potassium perchlorate, potassium chlorate, potassium chlorite, potassium hypochlorite. First, I'm going to talk about these names. When in an element, in a compound, look at the oxidation states of the ion. ClO is minus, K is plus. ClO2 is minus, K plus. ClO3 is minus, K plus. ClO4 is minus plus. Means the oxidation states have not changed anywhere. Oxidation states are -1 +1 for both the components, potassium side and also chlorate or chloride side, always. But the name change is different. Can you identify the pattern here? What is helping that to change the name? What's the difference between all four?
So the number of oxygen.
Very good. Number of oxygen. This logic applies everywhere. When the oxygen levels are very, very, very low, then it is called as hypo. Hypo is used. Then oxygen is little medium. Then ITE is used. Don't worry, I have given a card game. I'm going to teach you how to use it in the next class. ITE is used when the oxygen level are in the first stage. When oxygen are little more, then it's called as 8, chlorate. When there are more than expected, more than the maximum level, then perchlorate is used. Per example, hydrogen peroxide, because it is beyond O2. O2 was the capacity, but it went beyond one more extra, right? That is per is used when oxygen levels are more in the compound. So hypochlorite, 8 and perchlorate. In this case, potassium is +1. Everywhere you can see the +1, correct? So it has not changed. Oxygen is also -2 everywhere, but oxidation state of chlorine is changing. For example, KClO. What is the oxidation state of oxygen?
O2.
-2. It is not a valency, it is oxidation state. Two electrons. Oxygen has taken 2 electrons from chlorine and oxygen. Shashank, how can chlorine give oxygen to a electrons to a oxygen? I'll come back in the next slide. Because the chlorine valence is also -1. Can chlorine have positive valencies? I'll not say positive valencies. Positive oxidation states, I'll come back. But in this case, yes, it's a positive oxidation state. When I say -2 and K is plus, -2 + 1, how much? -1. So one more chlorine is required to compensate that. So +1 + 1, end of the day, KClO should become 0. Oxidation state of KClO is how much? 0. As a compound, KClO is 0. But inside, the oxygen has taken 2 electrons, chlorine has given 1 electron, potassium has given 1 electron. That is the state right now. How many electrons they have given will become positive, taken will become negative. In this case, let's try. Let's calculate. 2 into 2, how much? 2 oxygens are there. 2 into -2, how much? -4. -4, already 1 potassium is there. How many more chlorine required? -4. It is like this. Hold on, I'll show you. Just a minute, guys. Okay. Just a minute. My system hanged. Just hold on a minute. Sorry, guys. I think
Sir,
my
please
system
could
is.
you explain this slide again?
Pardon?
Sir, could you explain this slide again?
Yes, I'll do that. Awesome, man. I love that thing. Always ask. If you're not understood, please ask. I'm going to explain again and again till you learn. Hold on, guys. I'm just explaining. My system hanged. Just hold on. Okay. Now,
Sir, chlorine, how can be its balance +5 or +3 plus?
very good. Chlorine also has multiple valencies. -1 is very common.
Yes, sir.
Chlorine also gives 5, 1, 5 and +7 as their valency.
But sir, how it can be plus?
Perfect, which I'm going to explain in the next class, because we have to go to the shell configuration and see what the difference between valence electrons and valency, how chlorine can exhibit 1, 5, 7 also will be discussed in next class. Is that okay? It will be too heavy in this class. But chlorine can also exhibits, apart from that oxidation state of -1, it also exhibits +1, +5, and +7 also. That is like, wow, the information which you didn't know. But usually valency is 1. Oxidation state is -1. Example, NaCl, Na plus Cl minus. That's a usual one. But in this case, for example, KClO2, that is chloride. K is plus O minus 2 into 2. Correct? How many oxygens are there? What's the total oxidation state of this item right now? -4.
Sir, your screen is not visible.
Okay, sorry. Is it visible now?
Yes, sir. Yes, sir.
KClO2, nitrite. Okay. This oxidation state of potassium is how much? +1. Correct?
Plus
Cl, let's find out. O is -2. Correct? Then how many O -2 would be there? How many electrons? Oxygen wants now? -4. Very good.
-3.
Chlorine we don't know. X. How many we have from potassium side? 1.
1.
Okay. Then X is equal to?
Sir, x is equal to -3.
Oh yeah, because the other side. Yeah. I would not say -5 because this is a total oxygen requires so many. We are balancing the equation. So X is equal to 4 minus 1, 3. Correct? So what is the oxidation state of chlorine here now?
-3.
Yeah. Not -3, 3. Now let's see KClO3. Okay, let's do it here. So +1, X, and in this side, how many required? How many electrons are required? 6, right? So X is equal to how many? How much? 5. Did you get it?
Yes, sir, it is 5.
But don't worry, this difficulty will not happen in your books. But what I'm trying to say is, oxidation state will keep changing, depends on how I am participating in compound. But valency is different from oxidation state, and oxidation state is like a very hypothetical state. It's a theoretical value. In one compound, how many electrons I have taken or shared or given is oxidation number or oxidation state. Good to go?
Yes, sir. Yes, sir. Why do we need to know find the oxidation state?
Very good question. Why we need to do the oxidation state? Yeah, why should I know it? It's so much of tension. Why should I know it? Very good, very good. In each example, I'm going to show you. We'll do one thing. I have given you potassium permanganate. Okay. Using that, we will conduct an experiment. Everybody will conduct an experiment and see the magic of changing oxidation state in the same reaction. Okay. Let's wish to receive the kit as early as possible. Once kit comes to you in the next class, we are going to conduct an experiment where we are visually see oxidation state changing under its application. Shall we do that?
Yes,
Yeah. Practically we will learn it in the next class. Practically we will learn it. Let's wait for kit to arrive. If you have kit is with you, fantastic. Kit on its way, that's also fantastic. If school is not ordered, we request please order the kit at the earliest, so that I do not want to sit and blah 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 here. I also want children to experience the same hands-on sitting at their place. So please order the kit as early as possible. Another 60 schools have to order. Please do it fast so that classes would be more magical when children have the kits with them, the where they can conduct the experiments. Great. Let's go to the slide. Okay. Next is, okay, see this information which someone asked. Chlorine has oxidation number of +1, +3, +5, +7, also -1. Usually -1 is its regular valency, correct? Na? Then same way, oxygen has -2 and potassium is +1 most of the time. And sometimes oxygen can also have -1 as a oxidation number in case of peroxides. Great. But next week, let's watch it in our hand, why we need to learn about oxidation states and how it is magical and how can we know that oxidation state is changing. That we'll learn in the next class. I'm waiting for Kit to arrive so that that experiment can be magical. Okay. Okay, my next slide. Oh my God, one of the most torturous concept. How many of you agree with me? Not torturous? Very difficult? You don't feel
No,
so?
sir.
Okay. Do one thing, guys.
Keep doing.
I do not want to complete this in a hurry, especially this one. The booklet, we have beautifully written the same thing which is written in the booklet which is given to you. I want you to read it and understand this concept. Very simple. I want to say is that oxidation is giving away electrons. Reduced. I'm getting reduced. मैं छोटा बन रहा हूँ किसी के सामने. I'm becoming smaller in front of someone. Means I'm taking the negative energy from someone. I'm reduced. Sorry, I'm taking negative energy. Reduction is taking negative. That is taking electrons. Oxygen always gets reduced. Potassium permanganate. It's very, very strong oxidizing agent. I'll show you how. I'm going to take some glycerin. Okay. Again, you have potassium permanganate. I do not want you to scissors. I do not want you to use this experiment. Just a minute, guys. I forgot to keep the scissors. Everything is liquidy, and this will be there in your kit. But don't try this experiment with this one. Sorry, someone is trying to help. Tell me something I couldn't hear. See what I'm going to do. I'm going to clear that now. The beaker. This side. See this. I'm going to put the potassium permanganate here. Okay, this is a potassium permanganate. The potassium permanganate which is given to you is for a different experiment. Don't try this experiment. Okay, now I'm going to put, see there's a potassium permanganate and I'm going to put a drop of glycerin here and see what happens. Are you able to see that?
Yes, sir. Yes, sir.
So even it can cause fire also. Better I use my goggles. See? So it will catch fire as well. So it can create fire. Oh, see, there is a fire already. Are you able to see the fire? Are you able to see the fire? No.
No, sir.
So we can create fire without oxygen, without burning it. See that? There is a fire. Are you able to see that?
Yes, sir.
Yes, sir.
Because I put very little of the chemical. Okay, maybe you can put more potassium permanganate and put 2 drops of this glycerin. You will be able to see it burning. So that is a oxidation where glycerin is being oxidized. Okay. Oxidation is where I told you where it's going to take the electrons, correct? Reduction is where oxidation means the cations give away the negative part, give away the electrons. When it gives away the electrons, it gets oxidized. One who takes the electrons will become reduced. Oxygen is reduced. In case of example, iron in rusting, iron is oxidized, oxygen is reduced. Awesome, guys. Don't worry. We will keep discussing about this oxidation and reduction going forward also, and it will also there in the book. So try to understand the concept so that this is extremely important. And sometimes I used to get confused between ionic reaction and oxidation and reduction reaction. In oxidation and redox reaction, there will be a movement of electrons, but whereas in ionic reactions, there is a movement of ions. What's the difference between ions and electrons? Explore. Okay, hope you are able to read what I'm presenting here. Same thing what I told you. It can be even remembered like oil and rig. Oil is reduction is loss of electrons. Rig is reduction is gain. Reduction is gain. Oxidation is loss. You can remember it that way also. Okay, this is the same reaction which I showed you. This is not. I wanted you to balance the equation, but not today. And don't worry. Maybe metals and non-metals classes again. I'm going to show you how to balance the equation. Some easy tricks I'm going to teach you. I'm skipping this slide right now. And okay, I have a couple of maybe another 5 minutes. I'm going to conclude the class. I have a small previous year question. This is also there in your textbook. Just quickly answer that. Zinc reacts with silver nitrate to produce zinc nitrate and silver. What is the type of reaction?
Displacement reaction.
Displacement reaction.
Okay, can you please write down and balance it? Do it after the class. Potassium iodide reacts with lead nitrate. Wow, we saw it. To produce potassium nitrate and lead iodide. Very good. What is a reduction reaction? What is a reduction reaction?
Gain of electrons.
Reduction is where? Where? Things are reduced. Means electrons are taken in.
Gaining.
Reduction electron is gaining. Very good. So Fe2O3 plus Al, Al2O3 plus Fe. In this, what is reduced and what is oxidized?
Sir, ALO is
Al is oxidized and Fe is reduced. And one more quick. Sometimes I'll not be during exam. I'll be panicking, right? I'll be lots of stress. That time I'll not be able to remember giving electrons, taking electrons. So much of confusion. If oxygen is involved, it's oxidation. So a quick clue. Don't worry about giving electrons and don't go by definitions. Wherever there is an oxygen involved, that is oxidation. Al reacted with oxygen, oxidation. Because always oxygen takes the electron. So these are the hints you should follow and quickly do it. Fe2O3, Al is oxidized, reacting with oxygen, so oxidized. So good to go. Here also, very simple. Carbon is oxidized because oxygen is involved. Awesome?
Yes, sir.
Wherever oxygen is involved, make it a quick decision saying that is being oxidized. Very nice. Okay, so I'm going to. So I do not want to go here. Lots of theory stuff. I do not want to go here also. Only this is usually people get confused with corrosion and rusting and tarnishing. Corrosion is a broader term. In that, rusting is for iron and tarnishing is for silver and copper. Is it not?
Yes, sir.
Yeah. Always read this. This is important concept to read for your exams. And. Okay. Now one more quiz. Tell me which industry is this where chemical reactions are used? Which industry? Paper industry.
Yes, sir.
Okay. Second one, which industry is this one? Second one. Oh, girls' favorite industry.
Sir, matter.
Cosmetics.
Cosmetics. Cosmetics. Super. Which is this one? Metallurgy. Awesome. Which is this one?
Textile.
Construction materials. Construction. How about these ones?
Cleaners.
Cleaning. Very nice. Cleaning agents. How about this one?
Glue.
Very nice. Imagine, guys, most of the glues, most of the cleaning agents, most of the construction materials, most of the cosmetics, paper is still manufactured in India, but rest of it comes from abroad. Why can't we make them on our own? If you really learn about oxidation reduction reaction, if you know the oxidation states, if you know the valencies, if you know the chemical formulas, balancing equation, if you know the physical state change, chemical state change, and little bit of biology around it and physics around it, you'll be able to create all these things in-house, in India, make in India. Okay, I'm a big fan of entrepreneurs, and please learn these things not for exams alone. Also become one beautiful entrepreneur tomorrow. Entrepreneur is a person who does business with help of a idea, not like opening a kirana store. Creating an idea into a business is entrepreneurship. Entrepreneurship. How do you spell that? Entrepreneurship. Yeah. ENTREPRENEUR. So very difficult spelling, but entrepreneur. Entrepreneur is turning idea into business. So I want all these things to happen, should happen in India. Awesome, guys.
Yes.
Yes, you are the guys who can do that. Okay. And look at the next thing now. Career opportunities in chemistry. So this is also there in your booklet. So go and choose your career right now. And there are amazing stories to tell about how that origin of cement happened, glue happened, paper happened, lipstick happened. So everyone has a story to tell. Even the post-it papers are there, right? Even that glue is not that sticky. It is half sticky, but still it is of some magical application. So conclusion is chemistry is. So did you like the class?
Yes, sir.
Okay, now tell me, from the next class, what will change from this pattern? I'll get bored talking for 1.5 hours, only me talking, in between you people are answering. So I do not want that. Let's together do the experiment from next class. Is it okay? Okay, okay. So please, by next week, you should definitely get the kits and we'll make use of them. Other than that, what is the best part of the class? What did you like in the class the most? One by one. Type it down or one by one. One is experiments. Next. Not audible. Okay, practicals. Someone said teaching style. What next?
Line experiments.
Tell more. Doing chemical reaction. Very good. More. Yes, what is the next one? Quizzing. In between asking questions, that keeps you active all the time, right? Rather than कोई बोल रहा है मैं सुन रहा हूँ. सर हो गया क्लास, चाय पीने जाना है, पीटी पीरियड शुरू हो रहा है. उससे अच्छा है थोड़ा इंटरेक्ट करते रहो, बात करते रहो हमसे. That will make it more interactive. Class will be more interactive. You want that, right?
Yes, sir.
Awesome, awesome. And I am concluding the class. Maitreyi has some announcements. Okay. So before that, science is. Don't worry. This is a first class. Going forward, we'll make this more and more interactive, more fun. Okay, but please hold on, guys. Hold on, hold on. Go on mute, all of you.
Hello, everyone.
Hello,
Uh,
ma'am.
Hi. Please, I just wanted to request the teachers who have directly, because we understand there was some glitch in the portal today. So who have not registered their numbers, the teachers, this is announcement is for the teachers who have directly joined through the Zoom link and not registered in the Zoom, in the LMS portal of ScienceUtsav. Please, it will take just 1 minute. Just enter your school name and number of students so that your students' attendance will be counted by us. Otherwise, they will be left behind and we will not be able to track if your students had attended or not. So it's my request after the session. The portal will is now working properly. You do not have to rewatch the entire session again. You just have to enter their numbers in the portal. That's all I'm asking. And also from this time, we will also be having quiz, right, Shashank? Shashank, you're muted.
Guys, usually what happens when more number of people try to attend, then server goes down. Okay, I don't know. Somehow the AWS server did not match with the flow. Sudden rush of people. Maybe it went down for some time. Correct. Again, we kept the server up. It started working. Technology issue. And if any of you have missed the part of the session, not to worry. The recorded session is already there in the LMS. You can do it. Also, as Maitri is asking, what I want you to do is go to, hold on, learn.scienceuitsav.com. Maitri will also share these details saying if you missed the class, you can watch again. See this, you have to go to this place, Vigyan Jyoti this year's, click on this link.
You can directly register also. No?
Yeah, first is registering.
Yeah,
okay.
yeah.
I want them to school. This is teachers support where teachers has to write down how many people attended. This is for students to go and watch the things if they want to watch it again. So what we want to do is today's 18th session. Vigyan is the password. These are the links of the live sessions. This is recorded. Zoom will not get the recorded session, but in YouTube, if you go there, these are directly visible to you. The complete session will be visible. See, the live class is still happening in the same place. What are see? Same is going to come here. Okay, that is one thing. And if you can go and check out what is there inside also, some extra information. There are some important links also given. Apart from that, click on quiz. I want you to click on quiz. And click here to appear for the quiz. And here, I want you to write your full name, name of the JNV, and student ID. Where to get the student ID? Student ID, you can get it by evening. We are going to put that. I'll check whether the team has already put it. If it is learn.scienceuitsav.com. Okay, I think they already put it. Find your unique ID here and for the quiz. See, if you click it here, you are going to get the list of IDs for all the schools. If your name is not updated, whichever school has not given us the names, then we have put them as ABCDEF. So if you want your real name there, then please schools help us with the real names here. Correct? So this is a student registration ID. Maybe you can talk to your teacher and get your exact ID and put it in the quiz here. That will enable you to attend the quiz. Awesome, guys. So you can watch the video again. You can read and follow some other important information which is there. I request not to post any of these kind of information in the Zoom link, Zoom chat, because we are not going to consider that at all. We are not going to refer that at all. There are lots of schools who have put their attendees numbers in the Zoom chat, which will not be able to consider because system is going to generate that for us. Please take it from our learn.scienceutsov.com. Okay, guys. So meantime, please share your feedback. Last 1 minute, we'll conclude the class. Any more feedback you want to share it with us?
What, sir?
Any feedback you want to about the class? You want to say something?
Sir, the class was really very awesome.
Okay, what made it
The
awesome?
class was amazing.
Why? What made it awesome?
The experiments and the reactions.
Very nice. Then what else? I'm knowing this because I can make the class little more better going forward.
Because we can learn
And your
many things from
teaching, sir.
experiments.
And your teaching.
Okay, teaching style, very good. Interaction, someone said quiz and interactions. Also, there is an LMS to watch. Repeatedly, you can watch the program. Nice. Shall I tell you what was the best part of the class?
Potassium permanganate.
No, not potassium permanganate. The best part of the class was you guys, your energy levels. Okay? You guys, your energy level made it awesome. Keep participating like this so that we also get energy to talk to you.
Thank
Okay?
you, sir.
Science is cool. Science is awesome. Let's do it again.
Yes,
Okay. At the count of 3, 2, 1, go. Science is cool. Science is
sir. Science is.
awesome. Bye bye.
Science is awesome.
Science is really awesome, guys. Take care.
You too.
Thank you, sir.
Thank you, buddy.
Thank you, everyone.